So, Martine, I'm going to now share a problem that we're going to do together.
Right.
And so this is one where we have a farmer wants to enclose the largest possible rectangle using a straight river as one boundary and 2,400 feet of fencing.
Yeah.
What are the dimensions of the rectangle of largest possible area? So we know that the length is the 2,400 and we're looking for the largest possible area. Okay.
Right. Yep.
I'm going to go ahead and stop sharing that if you got that information. And we'll go back to the explain everything now that we can share the whiteboard together.
Okay.
I'm going to go ahead and draw a rectangle and then I'll let you take over.
Great.
Is the rectangle too big? Should I make it a little bit smaller? Yeah.
No, that's fine. I
There
think
we
I
go.
can pinch out too. So that's awesome.
Okay, good.
Okay. All right. So the problem tells us that a farmer wants to use 2,400 feet of fencing, but on one side of the proposed fencing area, there's a river, which we could say is on this side. And so we know that we're not going to need to include that in our calculations. Oops. Or we are going to need to include that in our calculations, right? And so to find the remaining area, we could start by first looking at the formula for the area, which is
perfect.
Area is equal to length times width. And here we know that 2,400 is going to be equal to 2 times L times W, or yeah.
Plus W.
Plus W, yeah. Width on the side.
Beautiful. Very nice. Okay, good.
One way to solve this would be to substitute our W. Well, substitute W by first rewriting the equation so that W is actually equal to something, which
perfect.
Might be something like 2,400 minus 2L.
Great.
And now we can plug this into our original formula, and we're left with area is equal to length times 2,400 minus 2L. Oops. 2L.
And in this case, I'm going to make sure that I put parentheses because right. All of that is being multiplied by that L.
Right. Yep.
And I'm just going to, for a second, I'm going to see if I can just move this part. Oops. Oh, that's okay. I'll leave it for now. I think that should be okay. Okay.
We can simplify that further. We can get the area to be equal to 2,400L minus 2L squared. And now I'm going to need your help for the next step.
Okay, perfect. What I'm going to do is let me see if I can move everything up just a little bit and get it out of the way. Yeah, there we go. Okay, so what I'm going to do is I'm going to just bring in a little bit of background material. We know that a quadratic or a parabola has the form of ax squared plus bx plus c, okay? And so this is what we have here. We have that the area is a minus 2L squared plus 2,400L, and then the constant is 0, okay? So when I look at that, that tells me from this that the leading coefficient is a minus 2. The second coefficient, B, is positive 2,400, and that our third coefficient is just 0. And we'll be using that in a second because we have something that when I actually set this equal to 0, I get a parabola that might look something like this. Actually, before I introduce that, I'm just going to introduce that if A is greater than 0, we had an upwards parabola. And what that means is that it has no maximum, but does have an absolute minimum.
Yep.
When I have a less than 0, that's when we get the situation where we have a max. And that's what we're looking at here because we have our A is a negative number.
Right.
So that's that part. And the second part then is if I actually draw a parabola and I find the zeros of the function. So I'll say that those are my two roots, x1 and x2. from the quadratic formula, I have two places where it hits the x-axis, possibly two. I could have non-zero or two. In this case, we're going to say, I'll do the case where we have two. We would have a minus b over 2a plus or minus b squared minus 4ac all over 2a. So that tells me that I have a number plus another number and minus another number. That's the plus and minus are standing for. So it means it gives me a number plus that number and minus that number. That just gives me the zeros. But really what I'm interested in is that number that's right in the middle, because that tells me the x value that is for the vertex.